Alrighty, so today we're looking at chapter 5i, solving linear equations using graphs. So we've been looking at solving linear equations, balancing both sides of the equal sign, moving the pronumerals onto the same side, but now we can also look at using graphs to solve them, okay? So some key ideas. Let's get my highlighter. You can find the solution to an equation by reading values from a graph. The strategy is called solving equations graphically. Okay, so remember, find the solution. Okay, it's finding x equals something, or finding y equals something, or any variable. Okay, so when we're finding the solution, we're trying to find the value of the pronumeral. And we can do that by looking at values from a graph. Solving equations graphically. Since you are looking for the x value that makes a linear equation true, okay, remember with this, the x value that makes the linear equation true. When we've done other chapters, and we always need to make sure we substitute the answer back in to the equation to make sure you get, 4 equals 4, because we know that that's true. 4 does equal 4. Okay, so we're looking for the x value where the linear equation is true. You read the x value for a given y value that forms a point on the matching linear graph. Okay, so we're looking at coordinates and finding which coordinates are on the point that match the linear graph. So, for example, to solve 5x minus 7 equals 3, you read the x value that matches y equals 3. Okay, so this is your actual y. Okay, so when does this equation equal 3? So y equals 3 here on the graph of this. So we're trying to find the x value. Solving equations graphically is a useful strategy when solving a large number of similar equations. Okay, so if you have, if you graph, a linear equation, then you can read a lot off it and solve a lot of equations quickly or easily. So yeah, it's a good method to use. Okay, let's do some examples. So here we have a graph. Okay, it's already given us the graph. It's graphed the equation. Using a graph to solve equations. So use the graph of y equals 2x minus 4 to solve each linear equation. Okay, so the name of this line, okay, is this, y equals 2x minus 4. So for A, all right, I'll write it here. We've got 2x minus 4 equals 2. So what that means is, what is this value? So what does x equal so that when your graph equals 2, or when y equals 2? Okay, because the y goes there. So if we look over on our graph here, y equals 2 is here. Okay, but we need to find at what point on our line. Okay, so when y equals 2, what does x equal? So if we go along here, okay, because we want the point on our line to be y equals 2, what is x here? Let's look down and look at what x is. It's 3. Okay, so what we can say is, well, we know y is 2 at this point, and from just looking at the graph, we know that x is 3. Okay, so the solution to this is x equals 3. Okay, just from looking at it. So usually, or what we've been looking at previously, is you just doing it algebraically, so solving. So for this question, you would have, added 4 to both sides and then divided by 2 each side to get x by itself. In this case, we've just been able to look off the graph. So let's have a look. I'll wipe all that out and we'll do the next one. All right, we've got B. So 2x minus 4 equals negative 8. Okay, so again, this is the equation of our line. Okay, so when does our line equal when y is negative 8? Okay, so let's look at y is negative 8. Okay, negative 8's here, and which means we need to move over to our line. So our line's over here, and we're still at negative 8. Y is negative 8, so that's good. Okay, so when we're here and our y is negative 8, that means our x value is -2. Okay, so from just looking at the graph, we know that x equals -2 when y is -8. Okay, because the coordinate here is -2, -8. Okay, and from our equation, it told us that y is -8, so then we can tell what x is by looking at our graph. All right, a couple more. We've got C. 2x minus 4 equals 0. So when y equals 0, so y equals 0 is here. So let's go down to our line, which is here. Okay, so when y equals 0, what is our x value here? It would be, oh sorry, wrong one. I've just gone down the wrong line. So let's go again. So y is 0 here, but see how all these values we go off this way? So I just went off the wrong way before. So here, when y equals 0, we're looking at the point here on that line. So that point. So what is x at this point? Okay, this point on our line, we know that y is 0 still at this point, which is good. And what x is 2. So we know that x equals 2 when y equals 0. All right, last one. Sorry about the confusion with that one. D. 2x minus 4 equals 1. All right, so looking at when y equals 1, because that's what that tells us. When y equals 1, we're looking at this point. And if we go down, what's x here? Well, x is in between 2 and 3, so it's 2.5. So x equals 2.5. Okay, so we've solved all of those linear equations graphically. We've looked at a graph to get our answers. All right, moving on. First one, we need to plot the graph of y equals 2x minus 1. Okay, so when we're plotting, we need to do a value or a line of coordinates. So we've got x and y. And you guys can just choose any values for x and we just substitute them in. So what I would do is put in a negative number, maybe -2, 0, 2, 4. That just gives us a bit of a scope of exactly where to put our dots or our points. So this is A. So we're just going to fill in our table. Okay, so when we've got y equals 2x minus 1, we're trying to find values for y. So for our first one, when x is -2, okay, so we're going to put in when x is -2, what does y equal? Okay, well y will equal 2 times -2 is -4, minus 1, which is -5. Okay, so -5 goes here. Then we do the next point. Oh, that didn't work. Okay, so now we're going to do 0. So y equals 2, we're going to put the 0 here instead, minus 1, 2 times 0 is 0, minus 1. So when x is 0, y equals -1. Alright, we're going to put 2 in there. So 4 minus 1 is 3, so the 3 goes here. And then y equals 2, 4, minus 1. 2 times 4 is 8, minus 1 is 7, so 7 goes here. Alright, so the reason we do all of this is so that we now know coordinates that our line runs through. So we can now put them on the graph. Okay, so when I say that, we've got -2, -5. Okay, so when x is -2, 1, 2, you go up to, or down to, -5. So there's a point here. Okay, then we go x is 0, y is -1. So there's going to be a point here. When x is 2, y is 3. And you can see that our dots are starting to form that linear line. When x is 4, y is 7. Cool. Alright, so now that we've got those, we can draw our lines straight through them. Now, I'm trying to find a ruler near me. It's It's really important to get this right, because if you're looking off the graph, it's going to be, it needs to be accurate as possible. So I've got my iPad cover here, so just give me a second. I'm just lining them all up as accurately as I can, so I can get a nice accurate line that runs through them. That will do. Alright, so I've just plotted my graph, and remember we always need to name it. 2x minus 1. We also should always name our axes. Alright, so that's A. So I'm just going to get rid of that, room for the others. Okay, and same as the question before, we're going to be looking at the first one. So it wants us to find x when y equals 3. So looking over at our graph, when y is 3, so 1, 2, 3, okay, what is x here? Well, x is 2. X equals 2. Okay. Then we've got II. This is interesting. 3, 2, 3. Anyway. 2x minus 1 equals 9. Okay, so when y is 9, so up here, what is x? So looking along here, well, x is 5. Okay, and the last one, 2x minus 1 equals negative 7. Okay, so when y equals negative 7, so looking along our y-axis down to negative 7, which is here, moving along to our line, what is x here? It'd be negative 3. Now that's if I've ruled it properly, which is why it's really important for you guys to be ruling these correctly. Otherwise it can really throw it off. So graphically is good as long as you are very, very accurate. These are much the same, so identify the graph to draw to solve each equation graphically. Okay. I'm probably going to leave it there because it's very similar to the ones we've just done. So see how you go and let us know if you have any questions.